Hello everyone, myself Mr. Sandeep, and today I am present here with a session on mathematics for class 12. In our last session, we have studied about the different types of the functions. We have learned how to prove a given function as one function, many one function, onto function, and into function, right? So we have also learned that one function is called as a injective function and onto function is called as a surjective functions. And further we have learned that if any given function is one function as well as onto function on the same time, then that function is called to be as a bijective functions, right? So I am reminding just the previous knowledge because this is much required for the next topic, right? So let's start with our next topic, that is regarding composition of functions and invertible functions. Before moving to our today's topic, let me give you or discuss a simple example with you, and that is from your general life. All of you are there in 12th class, and definitely you have passed out the 10th class from the board exams, right? So what is happening there? A student is given a roll number, and further while doing the checking, so sheets will be going for the checking, and for the sake of confidentiality, that roll number slips are removed from the answer sheets and code numbers are generated to the answer sheet. Okay, it means that answer sheet will not lost. Why? Because now indirectly that code number has been related with the student name. Clear? And in this way we are able to generate a system or the medium through which the student is now directly linked with the code number. Is it clear? So that is our topic for today. What this is called? So same figure is there given in your book also. See here. Your topic is composition of functions and invertible functions. Clear? What do you mean by composition? As the name suggests, composition means mixing more than one things. That is called as a composition. So here in the figure you can see the function f is defined from a to b, and there is another function g which is defined from b to c. Clear? And here we have got one new function, that is golf, which is directly linked from a to c. So whatever is given in the given figure we can explain here in wording. So they are saying let f is a function such that a to b shown in the figure, and g is another function mapping from b to c, that is here. And then composition of f and g is denoted by gof, that is called as a gof. Okay, so what is the composition of f and g? That will be gof only, such that now this function gof is mapping from a to c. Mean to say, now first of all it was linked, this g function was linked with the f function through this medium. Now it is directly linked here through a to c, given by gof of x, that is equal to g of f of x for all x belongings to a. Here x all belongs to a. Clear? So this is the method how to represent it or denote it. Gof can be written as g of f of x is equal to, now in the next step you can remove this o, g of f of x for all x belongings to a. Clear? So this knowledge is also required. That's very important for solving your exercise problems. Clear? So on the basis of this knowledge, I am not talking about invertible functions now. We are just dividing the whole exercise in two parts. First one is composition of functions. Second one will be invertible. So we will discuss it later when the question will come. Okay. So let's start with the exercise 1.3. Question number 1 is there. So you are given with a function f such that it is mapping from 134 to 125. So here it is domain and this is codomain. You can't say this is the range. This is the codomain, right? Another function g which is mapping from 125 to 13. Again same meaning. Now they are defining f. 1 is mapping to, here see, 1 is mapping to 2. You can draw the figure also. 3 is mapping to 5, 4 is mapping to 1. All these things are given to you in the question. You can check out from there. So also given, what does it mean? What is the meaning of this? This means this, f of 1. It means x is 1 and y is equal to 2. Value of function. F of 1 is equal to 2. F of 3 will be equal to 5. F of 4 will be equal to 1. Same is here. G of 1 will be equal to 3. G of 2 will be equal to 3. G of 5 will be equal to 1. So this knowledge we have gained from these two lines. Clear? Now the question is to find out GOF. So in the book or in the question, it is not written GOF of 1, 3, 4. You must have the knowledge that GOF. See here in the above definition, GOF is a function mapping from A to C. So what is the domain of GOF? That is A. So it means GOF will be found in terms of a domain only. So you will find out GOF 1, GOF 3, GOF 4. So what do you mean by GOF1? It means G f of 1. This is the method how to write down. Okay, now what is f1? See here, f1 is what? F1 is equal to 2, so we are just replacing f of 1 by 2. So what is g2? Now go to this line. G2 is equal to what? 3. Is it clear? Now GOF of 3, it means G of f of 3. What is f of 3? Find out from here. F of 3 is equal to 5. And what is G of 5? That is equal to 1. Similarly, GOF of 4, it means G of f of 4. What is f of 4? You can see here, find out from here. F of 4 is equal to 1. So we are replacing here by 1. G of 1, we will take it from here. G of 1, it is here. That is equal to 3. So like this, we have got the values of GOF at 1, 3, and 4. Is it clear? Now you can see your answer. X from the definition, the mapping of GOF is from A to C. It means domain is A and range will be from C only. This is your A, this is your B, and this will be your C. So A to C means this will be the value of X 134, 134, and these will be the values of Y, that is 1, 3. So see 1, 1, 3. Only two values you have got here. Clear? So this is your question number 1. Let's move to our question number 2. So in the question, it is given that let f, g, and h be functions. H, g, h be the functions from R to R, real to real. Show that f plus g of h is equal to f of h plus g of h. So this is theoretic question. So how to solve this? First of all, you will take the left hand side, f plus g of h. So for this, I told you in the starting only, you should know how to write down the method of writing this f plus g of h. So this oh, remove this o and put here h of x. Okay, then open this just like opening the bracket, f of h of x plus g of h of x, and further here you have removed the o and here you will introduce the o finally. Okay, f of h of x plus g of h of x, and now this time x will be removed, f of h plus g of h, and that is equal to right hand side. This is all related with the writing skill only. Okay, you just learn how to write down this f plus g of h, how to remove this o, and how to introduce the o. Okay, that depends on you and that will come with the practice only. Now come to the b part, f dot g of h. Okay, so can you write down f of h dot g of h? So this we have to prove it. Okay, let us see how to prove. F dot g of h is equal to f dot g, remove this o and put here h of x. Now after that, next step, f of h of x dot g of h of x. Next step, introduce the o, f of h of x, g of h of x. Next line, remove this s, x, you will get here f of h and into g of h. That is equal to what? Right hand side. Clear? I hope you have understood. Then come to your question number 3. Find the GOF and FOG if functions are given to you. F of x is equal to mod x and g of x is equal to mod f of 5x minus 2 is given to u. Here we need to find out first of all GOF. GOF is what? That is g of f of x. So you can write down like this, remove the o and write down like this. What do you mean by f of x? F of x is given here. You can see that will be mod x. In place of f of x, you will replace by mod x. Now what is g of mod x? In place of x, you will write down mod x now. Now what is your g of x? 5x minus 2. In place of x, you will just replace by mod x. 5 mod x minus 2 mod x. Clear? So you cannot remove this modulus. So this modulus is different from this. Now fog you have to find out. Fog is equal to what? You can replace this O will be written as f of g of x. What is your g of x? You can see from here. That is mod 5x minus 2. So will be written over here. Now what is f of mod x 5x minus 2? So just in place of x here, you will write down mod 5x minus 2. Now you see here two times I have written the mod. So whether you write one times or four times or 10 times, the meaning will remain same. Clear? So you can easily remove this one mod and you will keep only single modulus only. Okay? So that will be your answer. Clear? Then come to the question number 4. So in question number 3, I have left the second part and that is exactly same as we have done the first part. So that is your homework to complete second part. So without wasting time, let's move to our question number 4. If f of x is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 by 3 given in the book, show that f of x is equal to x. So we have to prove f of is equal to x. For all x not equal to 2 by 3, what is the inverse of f? After that, first of all, we will show f of is equal to x, and after that we need to find out the inverse also. Clear? So now to find the f of we will start from here. F of fx is equal to, can be written as f of x. Clear? Now what is f of x? This one value. So this will be shifted here in place of f of x. That is 4x plus 3 upon 6x minus 4. Okay. Now what is the meaning of f of this? It means in place of x here in the function, you will replace x by this whole value. Now wherever x is there, you will write down this one fraction. 4 into fraction plus 3 as it is whole upon 6 into fraction this one minus 4 as it is. Clear? Now after that all depend on your simplification or your mathematical skills. So fractions are there, you have to take the LCM here, take up the LCM, cut the terms, okay, and then LCM will be cancelled out here. So whatever is left here, that comes out to be x only after simplification. Okay, the this work depends on you because every student is having their own method of calculation. So go by your own methods, the easy and the simple one. Ultimately you will get the same answer, that is equal to x. Clear? Now what we have got, so therefore we have got f is equal to x. So we have proved the question. So f is equal to what? Ix. So Ix, that is identity function in x. Clear? So therefore f inverse f is equal to f. Inverse of f is equal to f. That is our answer. Clear? So when you will do the definition of the invertibility, you will come to know about this. If this situation is possible, it means this is the inverse of this. So f inverse is equal to f. Clear? So this only we have to show here. We need to find out the inverse of the given function f, and we come to know that the inverse of f is f only. Clear? So then let's move to our next topic, that is regarding invertibility. A function f such that x is mapping to y is said to be invertible if there exists a function g such that y is mapping to g. Clear? as the name suggests, inverted. Inverted means ulta. So a function f is mapping from x to y is said to be invertible if there exists a function g such that y mapping to x, such that gof is equal to ix and fog is equal to iy. Clear? So these are the condition for the invertibility. The function g is called the inverse of f. G is called the inverse of f, or you can also say that f is the inverse of G and denoted by f inverse. It means to say here G is the inverse of f and that is denoted by f inverse, or you can say f inverse is equal to G also. Clear? So look at the condition x to y then y to x. So same we can represent with the help of the figure also to make it very clear. So now see, first of all the function was explained and given to you, which is mapping from x to y. Clear? F function mapping x to y, and there exists a function g which is inverted. See the arrow, function f is defined from left to right and here g is defined from right to left. Mean to say whatever was the codomain or range of the function f, what was the range of f, that now becomes the domain for the g, right? First of all, for the function f, x will be x was the domain and y was the range, and here now y will become the domain and this will become the range. So that's why we are calling it as inverted. उल्टा हो गया ये, ठीक है? पहले x to y था, now it has become y to x. That means it has inverted. So how this is possible? There exists a function g such that y to x. How it is possible? So if f is invertible, then f must be 1 1 and onto. Okay, if f is invertible, then f must be 1 1 and onto, and conversely we can also say if f is 1 1 and onto, then f is invertible. So this is the condition which is required for you to prove a function invertible function. Clear? This we will use in the problems given in the exercises. So this is very important. Mean to say, if anyone is asking you to prove a given function as invertible, then first of all you will prove it as 1 1 function. After, in the second step, you will prove it as a onto function. If both proofs are there, then you can say the given function is invertible. After that you can find out the inverse. Clear? To make you understand clearly about the definition, let us talk about these examples. So here function, and this is also the function. Clear? So three situation I have discussed, I'm going to discuss with you. 1 2 3 is mapping to ABC. 1 2 3 is also mapping to ABCD. 1 2 3 is mapping to AB. So three cases we are discussing. Here in this, it is 1 1, 1 1 as well as onto, right? Single image, each item is having single image here, and all the elements are occupied here, no one is left. So this is called as 1 1 onto function. It means f inverse exists here. After that, come to the second situation. 1 2 3 is mapping to ABCD, but here 1 is mapping to B, 2 is mapping to A, 3 is mapping to C, but no pre-image of D is there, right? So agar hum when you will create its inverse, then this will be mapping to this will map to this, and this will map to this. Clear? So you can find out the inverse easily. But now here, when you have to find out the inverse, it means you will define a function from this to this, but D will be a element whose image will not be present in the this domain. Clear? It means it will not be a function. Agar function nahi hai, then it will be not 1 1 and onto. So inverse cannot be find out. Clear? Then come to the next situation. Many on one, many one, right? So when you will find the inverse, this will be mapping to 3. It means this will be having two images now, right? And in that case, if you know the definitions of the functions, how a relation is a function, in that case this will not be a function, ये तो function ही नहीं रहेगा. अगर function ही नहीं है तो inverse कहाँ से होगा इसका, ठीक है ना. So in this case also the function, the inverse is not possible. So there is only one condition, that is 1 1 on 2. Clear? I hope you have understood when a function can be invertible, right? So let us find out the inverse now. From exercise 1.3, question number 5 is there. State with reason whether the following functions have inverse or not. So in the question number 1, that is much very easy. You need to check out only that the functions are invertible or not. So here in the first part, function f is defined as 1 2 3 4 to 10. So you can easily say here, draw the figure also. It will be more clear to you that images of 1 2 3 4, they are only 10, single image. This is which function? This is many one function. Clear? Many elements are having only one image, that means many function. But for invertible function we need 1 1 and on 2. But this is not 1 1, since the given function is many one, therefore it will not be invertible. Clear? So come to the second part. In the same way, now the function is defined in such a way. If you are able to decide from here, then it's okay. Otherwise you can draw the figure also like this. 5 6 7 8. 5 is mapping to 4, 6 is mapping to 3, 7 is mapping to 4, 8 is mapping to 2, like this. Clear? So this is what, see, out of these two, 4, this one 7 and 5, both are having as its image as a 4. So this is, as because of these two elements, this becomes many one function, right? So it is many one function and not invertible. Okay, so even this is into also, because one image is left out. ठीक है, one किसी की भी image नहीं बन रही है. So it means when you will try to find out the inverse, it will not be having any image in the codomain, right? So therefore it is not invertible. In the same way, come to the third part. Here function h is defined as mapping from 2 3 4 5 to 7 9 11 13. So figure is given in front of you and mapping is also given here, 2 7 3 9 4 11 5 13. So we have shown the mapping through a figure. So it is now much more clear that each element is having only one image in the codomain, right? So it is one one function, one one function also, and even into function, onto function also. Onto means each element in the y is having its pre-image in x, so that's why it is onto function. So both conditions are satisfied. I told you earlier in the case of theory above discussed that any function will be invertible if and only if it is 1 1 and a onto function. So this function is both bijective function, so therefore it is invertible function. Clear? In the starting I told you the knowledge for the bijective function is required for this exercise. Now see here, a bijective function will be invertible function only. Let's move to our question number 6. See here, function f is defined from -1 1 to real, that is r. Clear? F of x is equal to x upon x plus 2, where x is not equal to -2. One thing is given to here, that here f such that -1 to 1 mapping to range f, specially given in the question. Okay, here it shows this is the range, not the real. So range of f. So we have to prove what here? Find the inverse, sorry, find the inverse of the function. Clear? Find the inverse of the function. They are not saying that this first of all prove this is a invertible function. So directly they are asking for the inverse of the function. But How we can find out the inverse? First of all, it should be invertible. So we are going to prove it as invertible first of all. For one function, if you remember, we are supposing let f of x1 is equal to f of x2. So put here x1 and then x2 here. Put them is equal to, from there you will get here x1 is equal to x2. So it is one function. After that, for onto function, we will suppose it what? We will suppose it as the given function is equal to y. We will keep it in terms of y, not for inverse. This is for onto. This is for onto. So we will convert x. We will find out the value of x in terms of y. Now after simplification, you will come to know that x will be equal to 2y upon 1 minus y. Now for every value of y belongings to the range, belongings to the range of a function, there exists the value of x also, okay, in the domain. So therefore it is onto function also, hence f is invertible. I have left here the line, therefore it is onto function. For all y belongings to R, there exists x belongings to -1 to 1. Clear? So if it is invertible, so therefore it is invertible. If it is invertible, then let this is equal to g of y. G of y is equal to what? That is equal to 2y upon 1 minus y. So for finding the inverse, we are keeping this term as equal to g of y. Okay, so where g is the function mapping from y to x, because this is the inverse now, right? So this is the inverse, so that's why we will write down it as a 2y upon 1 minus y. So in the definition, I told you that G is a inverse of the F such that GOF is equal to IX and fog is equal to IY. So these are the two conditions we have to prove. Then only we can find out, we can say that this is the inverse. Okay. So first of all, find out G of X. It can be replaced by G of F of X. What is your F of X? That is given at the top in the question, x upon x plus 2. And what is G of X? Now see, this is your g of y. In place of y, you have to put here x upon x plus 2 only. Clear? So 2 into fraction upon 1 minus y, in place of y this fraction. Simplify it with your own method, and ultimately you will come to know that this is equal to x. That is equal to ix, identity function in x. So GOF is equal to ix we have got. In the same way, you can find out fog, and you will come to know after calculation that fog is also equal to iy. That is again identity function. So we can say that fo fog and gof both are equal to identity function, that is ir, right? So therefore in this question, f inverse of y, that will be given by this one, 2y upon 1 minus y, because we have supposed let this is the inverse function, and so this will be the inverse of f. Clear? That is 2y upon 1 minus y. So this is your answer. Clear? I hope you have understood all these questions properly. So go through the basic knowledge of functions, their types, and how to prove the function is invertible. Okay, and then try to solve these questions of exercise 1.3 up to question number 6. Clear? And next, rest of the exercise we will do next time in the next video. Okay, till then complete this exercise 1.3 up to question number 6. I hope you have understood. So complete this exercise. Thanks for watching the video.